Professor Deborah Andrews. Before I formally introduce Professor Andrews, a little about the nature of the inaugural lecture. An inaugural lecture is a new professor's first opportunity to formally present to their peers and the public to demonstrate their contribution to and the journey they have taken in their academic discipline. And universities host them to celebrate with the wider academic community and society as a whole the achievements and esteem of their professorial faculty. An inaugural lecture is therefore a significant milestone in every professor's career, and we are here this evening to hear more about the contribution of Professor Andrews' work, its impact, and on the journey that Deborah has taken to reach this point in her career. At the end of Professor Andrews' lecture, as is traditional with inaugural lectures, there'll be no questions from the audience. Do feel free, though, to approach Deborah at the reception afterwards with any questions or comments on her lecture. And at the end of tonight's lecture, Professor Asa Barber, Dean of the School of Engineering, will present a vote of thanks on behalf of the university and us all. So Professor Andrews will be well known to most of you, and it's wonderful to see so many of her friends and colleagues here this evening. She's also joined here tonight by her partner Gary and her former PhD supervisor, Dr. Paul Ewing, many of her current and former colleagues and current and former staff. Welcome to you all. Before I invite Professor Andrews to present her inaugural lecture, I will just take the opportunity to share with you a brief introduction to Deborah's career so far, together with a few accolades from her colleagues and peers that may come as a total surprise to Deborah. Deborah initially studied industrial design at the Royal College of Art, moving from a very conceptual perspective to a focus on technical design with her PhD completed at Imperial College London. The focus of her research is sustainable design and manufacture. Until recently, sustainable development was often considered as something applicable only to developing rather than developed countries, and sustainability was generally associated with economics. Fortunately, perceptions of both concepts have changed significantly over the past 10 to 15 years, though the challenges to achieving a more sustainable world are increasing. Deborah has well over 20 years' experience in this area. She's published over 60 research articles and book chapters and is a chartered environmentalist. Her work enables her to collaborate closely with industrial partners, and she is regularly invited to speak at related business and trade events and leads training sessions for industry professionals. Deborah brings the classroom and her taught subjects to life for her students by drawing on her research, enterprise, and industrial experience, and in so doing, inspires future generations of designers and engineers. She is an active member of the Institution of Engineering Designers and a member of its Education and Training Committee and course and professional accreditation panels. Now, for some lesser-known facts about Deborah. Deborah speaks fluent Italian. She was part of the LSBU team that was involved in the Mad Dog solar car, now exhibited at the Science Museum, and participated in the Solar Car Challenge in Australia. She absolutely practices what she preaches and lives in an eco-home near Hampton Court. Colleagues working with Deborah have been quick to offer praise and recognition for her work and for the contribution that she makes to life here at LSBU. Her research colleagues, Dominica and Christina, say that aside from being an excellent professional, Deborah has been a determined vegetarian since the age of 16, is a passionate gardener and yoga enthusiast. In her private as well as her professional life, she takes her carbon footprint extremely seriously, going out of her way to make sure that when planning holidays, for example, she minimises her carbon footprint. This manifests in her professional life too, as was the case when she organised a trip to take design students to the Dali Museum in Barcelona and arranged for them all to travel there by bus from London. Deborah's colleague, Elisa Puccinelli, echoes the sentiments of a great many colleagues when she says, "I absolutely adore her." Deborah is hardworking, an inspirational researcher, and who has really led the charge more recently with recruitment activities, inviting schools to experience the taste of STEM subjects and visiting schools to share her knowledge about the circular economy, product design, thereby inspiring future generations. In her inaugural lecture this evening, Professor Andrews will describe how personal interest in green issues evolved into her professional interest and practice. For her, this underpins whole systems thinking and the integration of technological and human factors. She will explore the importance of design and engineering and reactive and proactive approaches to the challenges of sustainability and circularity now and into the future. Ladies and gentlemen, please welcome Professor Deborah Andrews as I invite her to give her inaugural lecture entitled Design and Engineering for Sustainability and Circularity. Deborah.
Hello everyone, I hope that you can hear me. I'm quite used to projecting my voice, teaching, etc. So I'll assume that you can hear me. Okay, my talk is Design and Engineering for Sustainability and Circularity, but it's also about challenging assumptions and busting myths. So I was brought up in a very fabulous little seaside town called Whitley Bay in Northumberland, and I'm a posh Geordie, I haven't got a broad Geordie accent. The town really developed at the early part of the 1900s when the what became a ballroom was originally built as a cinema, and it has been really made legendary in a Dire Straits song about the Spanish city, because eventually it was turned into a theme park. It's now been turned into a very fabulous set of restaurants and what have you. And the other second sort of major claim to fame, those of you who are very old might remember a TV series called The Likely Lads, and then Whatever Happened to the Likely Lads. Very important in my life. My dad went to Park Junior School with the guys who wrote the series, and I and my brothers also went to Park Junior School. So we grew up in this really beautiful place that is frequently, the images of the famous St. Mary's Lighthouse in Ireland are very often published in The Guardian. And in 2019, there was a little article about moving there, what's to like and what not to like. And the journalist said, Whitley Bay, for instance, while having suffered the usual despond when we all started jetting off to Benidorm, maintains pride and, importantly, its beauty. There are few finer or fresher walks than along the cliff edge between Tynemouth and St. Mary's Lighthouse. And then anything against it? Precious little. It's a delight. You've got to withstand the occasional wind straight out of Siberia, but that goes with the territory. And having swum in the North Sea, I can also say that the tides are straight out of Siberia as well. But it was a wonderful, wonderful place to grow up. So I moved to London to study, initially to work actually with handicapped children or children with disabilities, different abilities. And then went to Chelsea College of Art and Design and studied product design, then progressed to the Royal College of Art. During the holidays, I continued to work in community arts and play projects, and eventually when I graduated, I worked in consultancies and I was a freelance designer and designer maker. But people kept asking me to come and teach, and I ended up working a lot as a visiting lecturer on a whole array of further education and higher education design courses, and eventually ended up as a full-time academic here at London South Bank, where I've been extremely happy for an incredibly long time. Once I set up the product design course that I was employed to establish, and that was up and running, I decided, it would be a really good idea to develop my career and to study for a PhD, which I did part-time. I went back, and Paul Ewan has already been mentioned, my former colleague, was a teacher at the RCA in Imperial when I was studying there. Went and asked Paul's advice and said, I'd like to do a PhD, can you help me? And he ended up being my supervisor, and I studied in the Department of Mechanical Engineering. That was an absolutely pivotal moment for me. It really was transitional in terms of my career. So I became a fellow of the RSA, the Royal Society of Arts, got really involved with the Institution of Engineering Designers as well, and through membership there became a chartered environmentalist. And for somebody who hasn't got a degree in engineering, I became an incorporated engineer, which I'm quite proud of as well. And then through the IED, last summer, we hosted the annual Engineering and Product Design Education Conference here, the theme of which was DIRT, which was Disrupt, Innovate, Rejuvenate and Transform. We had a fantastic few days, and in recognition of that, I was really, really touched to be awarded a Medal of Appreciation by the IED last May. So that's enough about me. Let's talk about the important stuff. Sustainability, which for many people is about the environment, but actually it's not. It's about three things that need to be considered in balance: the environment, economics and social factors. There is absolutely no point in creating a product, for example, with a very low environmental impact if it's so expensive that nobody can afford to buy it, or it's made by children, or in slave labor conditions. So we need to think about those three things, or three criteria, in conjunction and find a sweet spot, a balance to find the best solution. Another thing, sorry, just have a drink. Another thing that's really important, I'm sort of quickly going through these to give you context. The circular economy, which obviously is very linked to sustainability, it is not just about recycling. That's a myth. And I'll explain about the linear economy in a few minutes. But the circular economy, it sort of mimics natural systems where once we've finished using stuff, we should be able to return either materials or they could be technical or natural. We should be able to return them in a closed loop, and they should be reusable in some form or another as long as that is technically and economically viable. The other thing that's really important is the circular economy is about not just recycling, but if you look at the waste hierarchy on the right of the screen, it's about factors like reduction, which is dematerialization, or increasing resource efficiency, making products that are not over-engineered, etc. It's about reuse, extending product life, recycling when reuse is no longer possible, and burning things or incinerating stuff so that you can reclaim energy, and finally disposing of stuff in landfill. And we need to move from this massive sort of disposal in landfill to a very minimal disposal in landfill to ensure that we can carry on living in a reasonable way and looking after people and planet, etc. as well. Carbon assessment has become very, very fashionable, and it's certainly a term that is now very common in government, for example. We think about net zero, etc., which is a wonderful ambition. How fantastic to be able to neutralize our carbon emissions or balance our carbon emissions so that we no longer adversely affect the climate. And that's a fantastic ideal. But if we only look at carbon, we are in danger of creating other problems. So the work that I do looks at many more impacts than that. So think about resource scarcity, ecotoxicity, water, etc. They are all excluded from carbon-only assessments. And just a little point of interest here, if you think about diesel cars, in the 1990s we were all encouraged to drive them because they emitted less carbon per kilometre driven than petrol cars. Fantastic. But we end up with a massive problem of particulates, and that wasn't envisaged or considered properly at the time. So that's a good example of why we need to consider more than just carbon if we're going to really create sustainable solutions to the problems we have at the moment. So Warren very kindly mentioned my experience with the Mad Dog Solar Car team. I suppose I had been interested in green issues, sustainability for a long time before I knew really how to phrase or talk about the subject. And when I came to South Bank, I was asked if I wanted to be involved with the solar car team, which was a fantastic experience. If you think these vehicles, and Mad Dog 2 is still in the Making the Modern World Gallery in the Science Museum, these really simple vehicles, they have an 8-metre square solar array, and they generate about the same amount of energy as a hairdryer. And they drive all the way from the north to the south of Australia, if you're lucky. I mean, there are lots of things to consider about, aerodynamics, etc., etc. So the team drove, took part in the Australia events and also travelling along Route 66 in an American event. Now, that was all really, really interesting, and I thoroughly enjoyed my experience, very much on the periphery of the team, because I wasn't an engineer, but it raised a few questions for me, which was fantastic. We've got battery electric vehicles, and everybody's saying that they're really sustainable. They're much better for the environment than petrol-driven and diesel-driven cars. But nobody was really thinking about the impact of drivetrains. They've all got different kinds of components. So what is the real impact? Is there any real benefit of these technologies, and how do they compare? And so this combination or intersection of embodied impacts and operational impacts became my sort of real passion. And as a result of which, I went on to study for a PhD in life cycle assessment and the design of ultra-low and zero-emission vehicles in the UK. And this was myth-busting as well. It was, challenging assumptions. First of all, I looked at hybrid vehicles, which was really challenging because there weren't many around. And I had to sort of go down to the local Honda garage and beg them to let me look at cars, borrow manuals to make drawings, etc. And eventually was able to put together models that looked at this intersection where you've got a petrol drivetrain or internal combustion engine drivetrain, electric drivetrain in the hybrid, but you've got fewer emissions. What are the real benefits? And I found that driving 10,000 miles a year, 16,000 kilometres, as long as the vehicles were recycled, there was a marked benefit. After, for example, and the life cycles were very slightly different rates of recycling, etc. After 1 year and 8 months, for example, you could go into sort of, let's say, environmental benefit, positivity, despite the fact that you had 2 drivetrains in the vehicle. I also looked at battery electric vehicles, and again took research that colleagues were doing at London South Bank, and I had a fantastic sabbatical. I went to Australia and worked with a research team there, and I used their car designs as a starting point to look at a slightly different component. It was looking at body shells and different weights of vehicles, because at the time everybody was saying carbon fibre was the most fantastic, wonderful, wonderful, wonderful material because it was really lightweight and you could travel further on less energy, etc. So I did lots of modelling and investigation, built a virtual car that had sort of optimum drivetrain, etc., and then looked at different body shells, steel, composite with glass fibre, carbon fibre, and then various other mixes and finishes, paint finish and embedded colour, and then looked at various recycling, landfill, energy recovery through incineration options for end-of-life treatment. And I focused on use of renewable energy, wind, solar and PV mixes rather than what was then the current mix, which was very heavily fossil fuel influenced. But the energy mix, those energy mixes didn't have a particularly big impact on overall life cycle impact. What did was the body shell. And this was really interesting. This myth about carbon fibre being the sort of saviour of automotive industry and so forth, I blew it out of the water because I found that if you have an aluminium chassis, which is sent to landfill at life rather than being recycled, the vehicle with the highest impact, although it was one of the lighter weight vehicles, it was painted and incinerated as waste. That had the highest impact. So it was a real surprise. And then a much heavier option, the glass fibre body. In this case, it had embedded colour rather than being painted, and it was recycled using a pyrolytic process, which is basically burning it in an oxygen-free environment with an aluminium chassis that's recycled. The key thing is it was glass fibre, and it was one of the heavier vehicles, and yet that had an overall much lower impact. So I was quite pleased to find this because you know, it was a great motivator to carry on looking at whole systems and not just cherry-picking elements of design or whatever that was supposed to be sustainable. You really need to look at the biggest picture to understand things like this. So I'll just very briefly talk about teaching. I've tried to be a champion of sustainability and sustainable design without being either dull or you know, preaching, turning people off, turning students off, being too worthy about this. And we've had some fantastic design outputs from all the years, different years, first and second years. Recently, we started looking at ways to reduce electronic and electrical waste, for example, and we've had some beautiful work. And then final major projects. The key thing in here, and going back to the, you know, the diagram of sustainability where we think about the environment, people and economics, we encourage the students to embrace those three criteria in their projects. So in the case of sustainable design here, for example, the wash box was a very low-tech product designed in conjunction with charities like the UNHCR, for example, for use in refugee camps. It was a flat-pack cardboard box that could use recycled plastic drums, and it was mechanically powered. Now you think, well, why would people want a washing machine if they're, you know, in refugee camp? They want a washing machine exactly for the same reasons that we do. But in a way, it's even more important because having clean clothes and being able to look after yourself is a way of maintaining dignity, and that's something that's stripped away from refugees. And then another project, this one I'm particularly proud of. This is a bit of a stormer. We're trying with first-year students, how can we get them really excited about sustainability? And I worked with, I must say that all the work from now on has been collaborative. My PhD was pretty solo in many respects, but all the rest of the work is collaborative. And two colleagues, Liz in psychology, Ben Lishman in the School of Engineering, we've been working on this project together. Rather than asking students to design sustainable solutions to challenges, they have to be bad and design the most unsustainable solution to a problem that they can possibly imagine. And they actually get points for trashing as many sustainable development goals as possible. Now, this sounds really, you know, it is upside down thinking, reverse psychology, but the students absolutely love it. And we've done all sorts of surveys and so forth and, you know, got great feedback. And they really remember, that's the key thing, they're thinking more deeply about this and they really remember what sustainability is about, etc. So the other thing, we've tried this last year at the staff conference where we asked a group of individuals to come up with ideas for being the worst teacher that they possibly could. Again, that worked very well. Because it really makes you think about what you do. And then this year, in September, again, Liz and I are off to the International Life Cycle Management Conference, and we're running a session with some very serious people there, so we'll see how that goes. But it's great because it's transferable. So the next thing is enterprise. Oh, and I should say that, you know, these three things, I've always sort of combined the three parts of my job, which I hope gives for a better outcome overall. So quickly talk about enterprise. I'm sure most of you are familiar with knowledge transfer partnerships. something that was set up in conjunction with the government in an Innovate Technology Strategy Board, as was, etc. And the projects employ an associate to work as a member of LSBU staff, but working with and for a company. And it's really, really valuable way of the company tapping into expertise and knowledge that they don't have to develop, you know, it could be digital or physical or whatever, product, services, etc. And the first KTP I worked on was with a company called IDC, Industrial Design Consultancy, and we developed some very simple sustainable design tools for the employees to use in the company, and also to take to work with their clients to improve sustainable profile of the company's output. And it was great because the associate was fantastic anyway, but what we did was introduce the students to the paper-based tool, and they tested it. So it's a really good way of educating the students, but at the same time getting feedback about the good and bad points of the tool. Then another KTP, and I've worked with some really sexy industries, I can tell you. There's nothing more enjoyable than an electronically programmable thermostatic radiator valve. So Chalmore, this company, they developed sort of low energy lighting, etc., and were broadening their product remit. And they came up with an idea for this particular product. And you can see Shaimel, the associate there, he's in the acoustics lab here, which was really important, testing the product to make sure that it wasn't too noisy when it was cycling through whatever. We tested it in the environmental chamber, you know, lots of really good things about it. However, when I went back to looking at, you know, that sort of combination of embodied impact versus energy savings, etc., or reducing environmental impact from energy saving, we dismantled a whole array of different kinds of radiator valve, including the bog standard one, a simple adjustable valve, etc., and then the electronic valve. And we found that unless you can save at least 16% of gas for your central heating, there is absolutely no environmental benefit of having this product at all. So it's nice sort of geeky gadget, but you've got to have really high energy consumption in your house to make it environmentally beneficial. The company weren't terribly pleased about that, but anyway. And then other projects, I've worked with the Commercial Refrigeration Centre on other KTPs. What's been fantastic about some of these is that Shaimel, for example, he was, I think it was a CAD, computer-aided design and engineering student who then went on to become an associate. And the same is true with Miguel, who went to work at Eppendorf. He got a degree in engineering product design. So it was a really nice career route and progression for him. And both of these projects were related to the design, one of catering equipment for the hospitality sector with under-cabinet refrigeration units. And the second one was designing special seals and things for very low temperature refrigeration equipment for the medical sector. So they were really good projects, and Katerina Kat, the associate with Adande, she won, was a finalist in award, the sort of national KTP award as a future leader, which was really good. So I've really learned a massive amount from taking on the KTPs, working with the associates, working with companies, etc. It's really beneficial for everybody, and the company's got expertise that they wouldn't have otherwise had. So last, we'll go on to look at research. So continuing in the commercial refrigeration area, the Bond Group, they started off manufacturing refrigeration equipment and cleaning it up, etc. And then they got into the business of remanufacturing, which, if you think, going back to the waste hierarchy, the second row down after dematerialization or reduction is reuse. And reuse, product life extension can be encouraged through remanufacture. But there are masses of perceptual barriers to this. people don't trust second-hand goods, for example. And it's weird because, you know, I guess most of us live in a house that was designed and built and has been lived in by somebody else. Many of you perhaps have second-hand cars, but there are lots of other products where there is very little trust in second-hand products. So the project that we were involved in was to try to find ways to encourage procurement teams, etc., to buy remanufactured products to reduce overall environmental impact. And so got a PhD, an industrial case award to do this, and one of the outputs was a carbon calculator, a very simple Excel-based tool that was to show the benefits of remanufacture, not just carbon, but economic savings as well. And they showed that compared with new equipment, buying remanufactured kit reduced the embodied carbon by about 50% and cost by about 30%. Now, to me, that's a real benefit, but the company still found that there was a lot of mistrust, and they wanted to understand why and how they could encourage more adoption or sale of remanufactured goods. So going back to our lovely carbon tunnel vision, one of the first instances of, or this is a great illustration, I guess, of the problem with carbon. This is a numerical or graphic illustration that shows exactly what the problem with carbon-only assessment is. Refrigerated display cabinets run 24/7. Okay, they switch on and off, but you know they're in operation 24/7. They use a lot of energy to do that, to do their job. And if you're just looking at carbon assessment, it appears that the operational impact accounts for about 85 or 95, should be 85, sorry, that graph's wrong, percent of of impact. And the embodied impact is minuscule. That's if you're only looking at carbon. Once you start looking at whole life cycle assessment, where you've got loads and loads of different inputs and outputs, the ratio shifts, and all of a sudden embodied impact is accounts for about 20% of overall life cycle impact, and operational impact, operational energy is about 80%. So carbon assessment it's indicative and it's useful, but it's not terribly accurate. So going back to the, we had a second PhD to increase market and use of remanufactured goods, and it was really around understanding behaviours and economics in order to reduce environmental impact, because the carbon calculator wasn't enough, it wasn't a powerful enough tool. Oop. So that resulted in the researcher developing a tool around procircular behaviours and refrigerated display cabinets. She called it the Procircular Behaviour Change Tool, and she adapted and transferred learning from the health sector actually to do this, how to best encourage behaviour change. And we got an award for the best paper at the Sustainable Innovation Conference in 2016. But what was really fantastic was that it increased the sale, the activities that we did as part of the project and afterwards, they increased the sale of remanufactured refrigerated display cabinets in a major international supermarket chain, German, and because they recognised the significant environmental and economic savings. That was a really positive output, and it was that understanding, you know, the behavioural aspect and nudging and pushing people. Another industry I've worked with a lot is the solar shading industry. First of all, started with a KTP to find scientific evidence to prove the energy-saving benefits of using blinds and shutters. It's common sense, really. You know, in hot, sunny countries, when it's the sun shining, you pull your blind down. We don't do it here. We tend to install products and just leave them. So the BBSA, the British Blind and Shutter Association, was set up to support members of the industry and really to encourage sales. But they wanted to find ways of sort of presenting scientific evidence to show all these benefits that were sort of known about, but people weren't practicing. So we started off developing a very simple tool called the shade specifier, which showed, and it was very generic, but it still showed, you know, if you shut your blinds in the winter, you reduce energy loss and you can save X amount on your heating bill. And the same for the summer for air-conditioned buildings. Again, we sort of engaged the students. The KTP Associate Cassie is there. We engaged students and ran lovely design projects. They had a fantastic time presenting to the members of the BBSA. And we also ran MSc projects with building services engineering students and got work placements. So, you know, it was win-win all round, sort of a lovely kind of ripple effects from the research. Then we engaged in a really big PhD for the BBSA. They wanted much more robust scientific evidence to promote the benefits of shading product use. And this project was very extensive. And it involved environmental, social, and economic benefits of shading products, and involved study of an urban flat, a suburban house, that was my house before it became an eco-house, and acoustics were really important as well for reducing noise in urban areas, and then looking at behavioural impact of blinds. One of the things, a lot of companies aren't interested in installing shading products in buildings. They'd much rather just switch on air conditioning because they don't care about energy use. Energy use accounts for a very small percentage of their overall operational costs. The big cost is employees, people. So how could we investigate people's behaviour in response to use of shading products? And there's some experiments in the Clarence Centre looking at just that. Blinds up, blinds down. How did people perform in a whole array of sort of psychology-based tests? But the big part of this, before we go on to this, go back to the operational embodied impact element of my passion, my obsession. Are blinds overall environmentally beneficial? Does the embodied impact outweigh the benefits of energy savings? So again, we did lots of modelling, lots of reverse engineering, breaking things, measuring, inventory building, etc. And then we've put together a whole array of different life cycle scenarios for different kind of blinds. Some were internal, some were external, because I'll tell you about that in a minute, external blinds, energy saving. But basically, we found that in very, very few instances, and generally you can see in this table, anywhere there is a red number, those are the only cases where blinds do not, or their use has a higher impact than the benefit of the energy saving. So mainly it relates to sending stuff to landfill if the products have a really short life. So it's advisable to keep your blinds for as long as possible, be they manual, motorized, or whatever. You can have them cleaned, etc., to prolong life. But that there is a definite benefit in terms of energy saving. So we went on to carry out a real-world case study, a block of flats in Camden that had horrendous problems. It was a single facade. It was originally built as a factory and was then converted into flats. And the windows, the opening windows were tiny, so there was no sort of through flow of air, and the building was just getting hotter and hotter and hotter in the summer. And it was noticeable that apparently there was a very bad smell because it was so hot inside that the water in the U-bend in the toilet was evaporating, so all the drain smells were going into the flat, and the laminate floor was also beginning to lift as well. So it was a fantastic opportunity for a real-world case study. You know, install some blinds. We know this building is overheating. Let's have a look at the impact of blinds. So the researcher Again, lots of nice opportunities to engage younger students in this. Little did they know that they were going to have to run up and down stairs, you know, measuring temperature inside, outside, etc. Kept them fit as well, so that was good. But we carried out a study over 20 days in a particularly hot summer, and then put the data together. So we had blinds on the outside, external blinds on the inside. There were a whole different series. Some were Venetian, some were roller blinds, etc. But on average, we found that using an internal blind helped to keep the room cooler by about 8 to 13 degrees, which is astonishing. I mean, this is partly because the blind, you know, the building is single facade, there's no airflow through, but also the orientation of the building. So, you know, you need to consider all these variables. So closing the blinds during the day was very, very beneficial. Similarly, or even better, rather than using an internal blind, if you used an external blind, that reduced thermal gain by 11 to 18 degrees, which is quite astonishing. And this was done in the summer when, you know, that we had a massive sort of heat wave, an extraordinary weather event. Now that's all fine. We got lots of great scientific data to, you know, show the benefit of this passive, low impact product that is not being installed in buildings correctly. And one of the issues, it turned out that modelling software is a real problem. So we had a couple of MSc projects looking at this and looking at overheating. And you can see on the graph on the left, we can see light levels, the blue bars, and then there are air temperature, etc. And that's a virtual model. The patterns of lux levels, etc., and edge, they're all over the place. What was going on in the real world and what the software could produce, there was a really big gap between that. And the same on the graphs on the right. If you look at the red line in both graphs, that's the real world data compared with what the modelling, the software was able to produce. In this case, we were using a package called IES. And it's way out. There's a problem. So one of the MSCs, the student investigated a heck of a lot more. And again, you can see the red triangles. That was this extreme weather event in August 2016 when we gathered all this lovely data. The temperature was rocketing. But the software, the two blue lines and the flat red line, it just couldn't reflect that at all. And the student found out that it was partly because the models, the software, and it depends what sort of software package you're using, it didn't have enough data to accurately reflect what was going on. And what's the knock-on effect of this? So a construction industry expert uses the software, says, what happens if I put a blind in a room? Nothing. You don't need to do it. You know, the temperature is not going to it's not going to rise above blah, blah, blah degrees. So blinds are not specified. So there's a big problem. You know, this gap between reality and digital scenarios. So we went on from there to a further PhD. Again, how do we find out? Well, we know there's a problem of the inability of software to model real-world conditions accurately, but in this case, we were looking at thermal loss and also at what people in the sector know. What is the level of professional knowledge? Excuse me. And through lots of surveys with construction industry professionals, we found that, unfortunately, and you can see the chart on the left, very often, construction industry professionals, they don't really think of using shading at all. And that's partly because the modelling tells them that they don't need it. And then if you look at the chart on the right, if they are going to use shading, what are the main reasons for doing that? And they state it's to improve thermal comfort, i.e. people don't get too hot in the summer mainly. And there was... what are the most common packages they use? IES within the sector is very popular. And that's one of the packages that has the most, or produces some of the least accurate results, unfortunately. So we did an experiment during lockdown. This was incredibly challenging. It was in my office, actually, in the tower block. We were really struggling where to go to do this work. And so we had to use the campus. And you can see on the right-hand side 2 thermal images here. The bottom one shows a window without a blind. So it's blue because there's losing a lot of heat. And the one above, there's a sealed blind, a very highly efficient concertina blind is dropped in the top image, and that shows how, through colour, the temperature is higher there. There's less thermal loss. So we carried out the experiments, or the researcher carried out the experiments here. And then again, she did lots of investigation, unpicking the software. Why wasn't it able to mirror what was happening in the real world and so forth? And the results, there were some quite shocking results, really. So the experiments were done overnight mainly, raising the temperature in the room to 24 degrees, and then turning the heating off and seeing how quickly the temperature dropped, etc. And we did scenarios with the blind down and without a blind. And various things, for example, we found that use of a blind reduced energy loss and therefore energy consumption. If you want to keep your room warm, you're going to turn the heater on. It reduced the energy consumption by 51%. Now, again, this is one particular location, so it is an indicative but very important study. Also found that things like glass temperature, window frame temperature, etc., the blind really acted as an insulating layer, which has a very positive impact on thermal comfort, so the products are really beneficial. And then looking again, real world and digital simulations, you can see the black dotted line in both of those graphs. One is the top one's looking at window surface temperature, the bottom at energy consumption. The really important thing here is it shows, and there are 4 different software packages, green, blue, red, and yellow lines. None of the packages could mirror, or mirror is probably the best description. None of the packages could mirror what was going on in reality. So in terms of understanding professionals, no wonder they're not speccing the right stuff because they're being given the wrong information, and they're making misassumptions about the benefits of shading. They, interestingly, at the moment, tend to consider external rather than internal shading. They're still thinking of shading, internal shading products as, cosmetic, decorative things rather than anything to do with building structure. But a key thing that they would consider blinds for management of overheating, but there was real ignorance about the benefits in terms of reducing energy loss, thermal loss, and therefore energy, saving energy. So that was a really good thing. Show people how you can make buildings more comfortable and sustainable. So with the software tools, there were various issues with that, but in all, the research highlighted there's a very definite need to improve the accuracy and robustness of packages, particularly for thermal gain and for thermal loss, and to educate professionals so that they really understand the benefits of these products. Now it's not rocket science, it's really fundamental stuff, but you need science to sort of back this up. And some of the really positive impacts of this these various projects. In 2021, the government published 2 reports. It was the Climate Change Committee, 2 reports that included the case study from the Byam Street flats. Fantastic. Here's real evidence. And people, well, I hope they take government reports fairly seriously. Another really phenomenal benefit, when the researcher was working on her PhD, she was also working as part of a building modelling group for SIBSI, And very recently, they have published a technical memorandum about the dynamic thermal modelling of basic blinds. So that's another really positive output indirectly from the PhD and research we've done here. And then the other thing is Low Carbon London project that we've done. Again, PhD researcher went on, and she's now a sustainability engineer at, working full-time with the BBSA, and they're developing really good training materials, again, in collaboration with us at South Bank. And the best thing, of course, is that we've now got people on the inside, experts on the inside. One of the MSc graduates is working developing IES software, so he knows the problems and hopefully he'll be able to solve them. And also working with British Blinds and Shutters, and Bahare is working with Mott MacDonald as a building physics expert. So really good follow-on. So I am going to overrun very slightly. I'll try my best not to overrun too much. The last industrial sector I'm going to talk about is the data center industry. And this is something that I found quite fascinating. Since the introduction of modern computing, which was really during the Second World War, 55%, and in particular since the introduction of the World Wide Web in the late 1980s, 55% of the global population have become connected. They use either laptops, phones, or whatever. They are digitally connected. And data traffic is currently about 4.2 trillion gigabytes a year. So it's a massive, massive, massive industry has grown up to support this. Around the world, there is an estimated 7 million data centers. They might be the size of a cupboard, or they might be the size of 9 football pitches, the hyperscale centers. There's a concentration in Europe, in the UK, Germany, France, and Netherlands because of all the financial industry, and there is huge investment in this sector. But for a long, long time, any nod to sustainability in the sector has just been about energy efficiency, and everything else has been ignored. So, of course, this represents a great opportunity to think about, that intersection of embodied impacts and operational impacts. How can we really find out what's going on in the sector from a sustainability perspective? It's absolutely apparent, and COVID really, really highlighted this, it's apparent that we are addicted to digital technology. And certainly during lockdown, an awful lot of people relied on it entirely for education, health, videos of kittens, whatever you want. But, this graph shows here a sort of increase in data traffic during lockdown. The speed and scale of development of this sector mean that it has not developed any kind of circular thinking or process whatsoever. It developed along a linear model of consumption because the sector, their focus and emphasis is service provision. You know how frustrating it is when your internet goes down or whatever. It's and how that might be annoying if you're watching your favorite TV program, but if you are reliant on that for healthcare or whatever, it could be catastrophic. So the sector concentrates on 24/7 uninterrupted provision, and it has grown up along a linear model of consumption where we take resources, we make stuff, we use it, and then dispose of it. And there are various reasons for that. One is the way in which products are designed. They're not designed to facilitate disassembly. They have short lifetimes, etc. But also, there is not an infrastructure or an adequate infrastructure for recycling electrical and electronic products. It's terribly, terribly underdeveloped. So even if we wanted to recycle stuff, we can't. We've got too much and too little provision for recycling. Now, this is a huge problem now, and it's going to get even bigger because if we use 2018 as a baseline, in the EU, by about 2025, the sector will have grown by 300%, and by 2030, it will have increased 500% around the world. So we're generating more and more data to do more and more digital activity, but we're also creating more and more electronic waste. And by that, if you think, data centers are basically, let's say, a building or a room, and they are full of things. Servers are basically computers without screens. They're full of bits of equipment that store and process data. So in about 2010, I think, a colleague who's here this evening, Robert, proposed a PhD. At the time he was working with HP and wanted to investigate the real physical impact of a data center. So we did a PhD around that. And okay, the operational impact was certainly the highest over life, but the embodied impact of all the equipment was really, really significant, and it wasn't being considered at all. So 15% of the embodied impact in a building, that's in a building that lasts 60 years. The mechanical and electrical systems last about 20. You have backup batteries in case there's power failure. They last about 10 years. But the computing equipment, the data processing and storage stuff, generally lasts between 1 and 5 years. So there's a big, big problem here. And 85% of the embodied impact derives from that computing and IT equipment. So that was probably the first time that a data center had been assessed in this way. So, electrical and electronic equipment, obviously IT falls under that bracket. At the moment, we're generating about 6 kilos per person around the world every year. That's equivalent to 50 million tons. If we carry on doing what we're doing, by 2050, it'll be about 120 million tons a year, which is not only bad for the environment, it's wasting masses of resources and masses of money. So at current value is about $62 billion of stuff that could be recycled. Globally, only, and it's less than 20%, estimates say about 17% of electrical and electronic equipment is formally collected and recycled. And the rest, there are sort of hidden markets where stuff is resold. A lot of stuff actually ends up just being dumped and chucked in holes in the ground. It's really bad. Since the sort of early to mid 2010s, 15, the EU suddenly began to get really worried about a group of materials described as critical. That means that they are of high economic and technical importance to the EU, but there is a threat to supply chain. And guess what? Lots of those materials are in data center equipment, but they're also in renewable technologies like wind turbines. So unless we do something about recycling them, reclaiming them, closing that loop in the circular economy, we're going to end up with really major problems. So in 2021, the EU got even more wobbly. So, oh my gosh, not only do we have 10 critical raw materials, we've got about 30 that are on the risk list now. So there's been a real drive to try and encourage or to identify ways to reclaim these materials. A lot of the key mines are located well outside Europe. A huge number of critical raw materials are found in China. And the Chinese government said, "Ooh, we don't want you to have them. We want to keep them for ourselves. We will export these materials in products, but we're not going to support the raw materials." So recycling, if you want those materials, you have to recycle and reclaim them. It's your problem. So there's been a lot of anxiety about this, and many other materials are found in terribly politically unstable areas, like tantalum, which is critical for capacitors that are in your phone. The main area where they're located is Democratic Republic of Congo in Central Africa. And there, the mines are not run by government or legal bodies. They're all hazardous and highly illegal and very unethical. So all of this stuff, the learning from the PhD and subsequent work in the area inspired me to try and develop a project, put a team together, and to develop a project, SADASI, which is a circular economy for the data center industry. And the second sort of pivotal thing for me, in 2017, I won a research sabbatical, which absolutely transformed everything. It meant I was still supervising PhD students, but I could spend the rest of the time writing a bid, and it was fantastic. We got funding from Interreg, which is part of ERDF, Interreg Northwest Europe, a huge sum of money. First of all, we got funding to the project value 3.2 million euros, and then an additional project. So in total, we've had 4.4 million euros value to support this project, which I think is real evidence that the EU are very keen to do this. So I spent my sabbatical building a team of people, an international team, people in France, Germany, etc., the Netherlands, and we identified 14 key subsectors within the industry. And the whole project uses whole life thinking. It's a unique initiative. We tried to make it as, the scope as broad as possible, because absolutely everything that happens in individual areas of the project affects, or this industry rather, affects absolutely everything else that is going on in the industry. So you've got to understand the big picture in order to initiate change. And one of the great things, we've done a lot of work with various industrial partners, and people were saying to us, you know, we're bringing together representatives from the different subsectors, and people were saying, I've never talked to anybody from that bit of the industry or that bit of the industry. You know, I'm really learning. And they were building business links as well as sharing knowledge. So it's incredibly beneficial. So we have this whole life thinking approach, which is critical to accelerating development of a circular economy in any sector really, but particularly this one. And the aim is to reduce waste, to prevent supply chain problems, and ultimately to ensure uninterrupted data center operation and service. Now the project, for those of you who aren't familiar with design methods and design thinking is something that designers have always done, but it was really sort of epitomized and packaged very neatly in about 2005 by a guy called Tim Brown, who's the CEO of IDEO, which is a major globally significant design consultancy. And design methods, again, the design process and method is something that we've always done, but the Design Council neatly packaged it in their double diamond. First stage, discover, then define what you're doing, then develop your proposal and deliver. But there's an awful lot of iteration in the process. And this was the methodology that underpinned the Sadasi project, and I think is one of the reasons why it has been so successful. So we've had transnational cross-sectoral collaboration with over 20 full-time and associate partners in all those countries. We've had co-creation workshops, working groups. We've built a network of over 100 members, etc., and it's really paying off. And we've run 3 pilots: design and manufacture, life extension, and end of life. Design and manufacture is based here. We're leading that pilot. And what we're doing is taking all the data that we've collected through the pilots, and it is feeding into the development of a digital tool, the Circular Data Center Compass. And this is coincidental. In 2020, the EU published their Circular Economy Action Plan, and post-Brexit, the UK published a document that's almost identical, the Circular Economy Package. But in this, I mean, and we sort of preempted all of this stuff because the project, Sadasi, started at the end of 2018. But the EU, etc., identified that there's a real necessity to develop or the potential for circularity is very high in areas like electronics, IT, and batteries. So the Sadasi project really, you know, was absolutely bang on in terms of need and potential. And there are 35 key actions in the action plan, and 24 of those directly relate to the data center industry. So what we were doing through the Sadasi project was sharing knowledge, etc., and helping industry to preempt what is coming in. These are guidelines or action points at the moment, but they are gradually beginning, to be turned into policy. So if you're ahead of the game, you've got a business advantage, and it's also better for the environment and people who are making electrical and electronic equipment. So a distinct feature in our project, apart from the fact that we've brought together lots of people who don't normally talk to each other from the various subsectors in the industry, is we're using primary data. Again, this is very, very rarely done. Lots and lots of models of things have been constructed, but they've used secondary source data and assumptions and extrapolations based on really old data. So we roll our sleeves up, take things to pieces, make inventories, identify all the materials, the manufacturing processes, send a lot of things in particular like the printed circuit boards to France, to our fantastic recycling partners, TND, who then process the equipment, grind everything up, and then process, well, it's no longer equipment, but what's left of the PCBs, they process it thermally and chemically to identify exactly how many types of materials and how much are in PCBs. Now, that hasn't been done before to this level. The other thing that they are doing, which is fantastic, is developing recycling processes to reclaim a lot of stuff, critical raw materials, that at the moment are not reclaimed. In recycling, electrical and electronic stuff, iron, steel, copper, aluminium, and gold. Those are the only 4 things that are really recycled and reclaimed. And yet there are loads and loads and loads and loads of other materials in electrical and electronic equipment of high value, but they're in really small quantities. So unless you've got a huge sort of critical mass, there's no benefit in recycling. Or the recyclers say, well, we're not going to develop processes to recycle that stuff because it's not economically viable. But until you build the recycling centre, people aren't going to collect the stuff to recycle. So it's a vicious circle. We need a sort of something to really kickstart all of this properly. Again, going back to comparing carbon and full life cycle impact, if you look at, and these are, again, indicative results because they are from sort of particular servers. On the left, you've got a typical carbon assessment of an old server, which was not energy efficient. And you can see the ratio of operational impact is about 85% over life, and embodied impact is 15%. That's a carbon study. And slightly newer and more energy efficient server, again, the operational impact appears to be about 80% over life and 20% for embodied impact. Carbon studies. Whole life cycle assessment studies are very different. The older server, we see the ratio shifts to 70-30 for embodied to operational. But look at the bars on the right-hand side, are really new, and don't forget, in older and newer servers, there are material differences or masses of material difference, etc. But in the newer servers, the ratio shifts to about 50-50 embodied to operational impact. So why hasn't industry been taking this on board and recognizing, all this stuff that is just being wasted? It's bad for the environment. It's bad for the people who make the stuff. It's economically bonkers. It just doesn't make sense. We hope that we are having a positive effect and we are creating waves. It always strikes me as rather ironic that an industry that has facilitated so many disruptive businesses, think about things like Uber, for example, that turned taxi rides upside down, why can't they disrupt their own business instead of carrying on doing the same thing that they've always done? Don't know. Anyway, we have developed our Circular Data Center Compass, which is a free online resource, a tool to help people in the industry to make informed decisions about their procurement choices. And we consider in the tool environmental impacts. These are the SADASI indicators, what's measured. And you can see the environment, it goes way beyond carbon. Yes, we're thinking about climate change, but also resource depletion, human toxicity, etc., etc., etc. We've also, and this is a very sort of nascent discipline, social life cycle assessment. And again, you know, I mentioned before that I've been working with an amazing team of people, specialists. We've all got our sort of strengths in different areas, but we've all collaborated a lot in all the elements of the project. Social life cycle assessment, it's very difficult to measure, but using the United Nations very newly introduced methodology, our colleagues in France built a tool, a way of measuring this, but it was all through interviews. So I spent hours talking to people and collecting data to put together. And then, last but not least, the economic impact, incredibly important. Bog standard sort of formula here, capital costs plus lifetime operation costs plus maintenance costs plus disposal minus residual value. So that, in a way, was the simplest model in there. And then, this is something, again, a very new activity is criticality assessment. And the EU and other bodies are incredibly interested in this because of the reliance on these materials. How on earth are we going to improve our use of these materials? What's going to become threatened in the near and the longer term? So again, our French partners, they've got experts in this area. They did a lot of work on criticality. It's helping people to predict where problems might lie. But also, in terms of our tool, it's also raising awareness about criticality. So this is the last little bit of the presentation, the compass. And this project has sort of started, if you can imagine, 10-mile wide or 10-kilometre wide data set that's just been refined and refined and refined and refined until we get to everything sort of fitted together and we have the compass as an output. I don't know how many person hours have been involved in making this, but again, fantastic opportunity. The guy who did the back-end work for the compass, he was a South Bank student studying for a Master's of Research. So, and he's now gone on. He's still working on this a little bit in the background, but he's now progressed to doing a PhD. And the front-end design was done by one of our PD graduates. And an EPD graduate has done a massive amount of work in other areas as well. So really nice sort of career progression for our students here. So Compass, you have three options. The interface is designed to be as accessible as possible. You have a compare option where you can see you have a server, a piece of equipment, perhaps it's not doing exactly what you want it to do. Can you replace components? And if you do, what are the benefits or otherwise of doing that? End of life is about retiring your product. What's the best option? Is it best to take something out of service and buy a new bit of kit or to extend life? And then there's the design evaluator. So compare, everything is, again, really easy to use, just drop-down menus, etc., for a whole array of different components. And the results are presented in a disaggregated way. This, again, is unique to the tool. Most life cycle results are presented, so you don't know what's environmental, economic, or social. The results are aggregated. So we've separated them out. So as an end user, you can make decisions based on your company's priorities. Is it social concern or economics, for example? And then at the last bars on the left, right, we have the criticality risk, and that's just really raising awareness. If you change configuration in the server, how does that affect the criticality of the embodied materials, or the level of criticality, etc. End of life, options here: do you refurbish and reuse? Do you recycle using current industry methods, or using our sabbatical recommended method, which increases reclamation of critical raw materials? And the last thing we put in landfill, not because we advocate it as a good practice, but simply because it's a very valuable benchmark. It highlights the benefits of recycling and reuse. And then again, the tool will give you answers. You can see focusing on one particular impact set, like environmental, or on different options. Do you want to look at the environmental impact of different end-of-life scenarios, etc. So simple, well, we hope the results, the information is conveyed simply and accessibly, but without compromising data quality. And the last bit of the tool, again, something we developed at South Bank. The researcher, Chris, is a former EPD student and now studying for PhD, as well as doing her day job. 80% or up to 80% of a product's environmental impact is determined during the design phase. So design is incredibly, incredibly important. And this is where I guess the difference between the work or the elements, reuse, the compare tool, recycling, etc., that is all reactive, looking at the mess or pickle that we've got. What do we do with all this e-waste, etc., reacting to this current situation. The design phase is very much the proactive bit. The missing link in a lot of industries is really good design for circularity to facilitate increased recycling rates and reuse, etc. So the eco-design evaluator was developed to do that, to help designers to comply with the various criteria in the Circular Economy Action Plan and other guidelines. And the tool, it's live, so as you change criteria, the spider's web changes shape, so you can see how circular or otherwise your product is. And then you've got a little indicator at the bottom. It's 81% circular, whoopee, or what? And then the final output from us at South Bank so far has been our prototype server, which is reduced mass really significantly by overall mass. So thinking about, that top bit in the waste hierarchy, dematerialization, increased resource efficiency by reducing mass by about a third, rationalize the number of components to make disassembly, etc., much easier. It's got a modular platform. The components are consistent because, again, most servers, designers come along and think, oh, great, new project, oh, change everything. So you can't take, an item from a component from one server from generation 9 or 10 and put it into the next generation because they don't fit. The lids don't even align because they have screw holes in different places. So this is all, it's a modular proposal. We are trying to get this in prototype produced at the moment, which is proving a bit challenging, but hopefully we will get there. And then we'll be able to take it to industry and say, look, we've done it. How can you change what you do? So the impact from Sadassi has been quite phenomenal, really. My goodness, sorry, I'm going on a bit. We've developed an inventory of primary source data through all life cycle stages. These are firsts, by the way. We have life cycle and environmental impact assessments for a whole range of servers, comprehensive critical raw material inventory and life cycle assessment. We've got the criticality indicators for the servers. We've developed a pan-sectoral social life cycle assessment for the sector, whole life cycle and systemic LCA tool for equipment, the eco-design evaluator, really important, and a prototype circular server that will address all these impending criteria in the action plans and packages. So if people adopt that, they're definitely going to be ahead of the game because things like the right to repair are now becoming policy. We've delivered training to over 100 professionals from 52 SMEs and 32 bigger organisations. We've had a minimum of 12 conference and journal papers. We've got more in the pipeline. We've got over 20 blogs and interviews and articles and trade press, 71 industry events and conferences in the UK, EU and around the world. And we are influencing EU policy by meeting and discussing the project with members of the EU Commission through their sort of middlemen or agents. And the last things that we're going to do, well, we're carrying on our training events, but our data, EcoInvent is the most comprehensive LCA database probably in the world, or certainly one of the most comprehensive, and we've been asked if we will contribute our data to that, which is brilliant because it's, you know, sharing information globally. And then our circular server, we want to build a prototype, but we will probably publish the information on an open platform like Open Compute, so everybody can have access to it. No one manufacturer will have an advantage. So that's my life since a few years, and there are so many people to thank. I wouldn't have done it without them, and I've probably missed some people off this list. There are, you know, people I've worked with for many, many years and people I'm just starting to work with, which is really exciting. Lots and lots of collaborators, students, staff, industry members, etc. And also the admin staff and technical staff in the university and administrators in the Sadasi project in particular have been absolutely brilliant. We couldn't have done it without, you know, everybody pulling together. My colleagues in the mechanical engineering and design teaching team, and then I must have taught at least 1,000 students since I've been here. Like it, well, their loss, their gain, who knows? But it's, you know, without all of these people, I certainly wouldn't be standing here today. As Albert Einstein said, what a hero. We can't solve problems by using the same kind of thinking we used when we created them. I think we need to shake things up and make change. And I really hope that I'm doing that. And thank you very much for listening.